Alright, so we left off with types of experiments. We kind of went through the different vocabulary, and there's two different kinds of experiments, so I'm going to explain each one. The first kind is called completely randomized, and you just do your experiment completely random. You take, so for this example, a farmer wants to determine his optimal level of fertilizer for his crop to maximize the yield, or how much of his crop he can get out. And he's trying to optimize the level of fertilizer. So he would take all his plants and he would randomly assign them to 3 different groups, not based on anything, just randomly. His first group would get 20 plants, 20 more plants in group 2, and 20 plants in group 3, not based on anything, just totally random. Group 1 would get no fertilizer. Group 2 would get a little bit, and Group 3 would get a little bit more, and those would be your 3 levels or treatments of fertilizer. And then he would measure how much of his crop he got out from each of the different treatments. Completely random, based on nothing, just separate, do the experiment, and compare your yield. That is a completely randomized design. The other type of design is called matched pairs, and it is what it sounds like. You pair up your individuals based on a certain characteristic and run the experiment parallel with the pair to be able to compare a little bit more closely based on a certain type of characteristic. So in this example, they're trying to see if listening to music has an effect on a student's ability to learn. So they start by matching the students according to their gender and IQ. So they've matched them based on gender and IQ. So male with another male with a similar IQ, female with another female, similar IQ. And with each pair, they'll randomly assign one student from each pair to the treatment, and the other student will not have the treatment. So it's one gets it and one doesn't, and they're paired together. Then you will administer the treatment to each pair together, so person A and person B, one gets it, one doesn't, and each pair works the same way. And then for each pair, you'll compare the difference in the scores on the exam based on just the pair, and that way the IQ and the gender is separated out. So it's a little bit more specific, a little bit more time consuming, and gives you slightly more accurate results, kind of trying to control for some of those confounding variables. So that finishes up page 8, the difference between completely random and matched pairs. Now we're going to look at an example and try to look at the different characteristics of the experiment. So now we're on page 9. So it says Lipitor is a cholesterol-lowering drug, and they had a study. They studied the effect of Lipitor on cardiovascular disease. It had 2,838 subjects, different ages from 40 to 75. They already had type 2 diabetes and without prior history of cardiovascular disease. So they have a very specific group of people. It is a placebo-controlled experiment. It is double-blind. Subjects were randomly allocated to either Lipitor or the placebo and were followed for 4 years. The response variable was the occurrence of any major cardiovascular event. And they found out the conclusion of the experiment is that Lipitor significantly, we'll learn what that means later, significantly reduced the rate of the major cardiovascular events. And so, question A, what does it mean for the experiment to be a placebo-controlled? That means that some individuals receive a fake treatment. So some individuals get a fake treatment. And again, we only really have to do that for humans because we're the only ones that would know. What does it mean for the experiment to be double-blind? And that means that neither the subjects or the administrators have any knowledge of who got what. Somebody knows, but not the subjects or the administrators. Someone else knows, maybe the computer knows, maybe a third party knows, but the subjects don't know, and the administrators do not know. What is the population for which the study applies? So the population is everybody age 40 to 75, with type 2 diabetes without prior history of cardiovascular disease. So our sample came from this population, again, ages 40 to 75, with diabetes already, without prior history of cardiovascular disease. Very specific population, and from that population, the sample is the 2,838 subjects. The treatments, you either got 10 milligrams of Lipitor or 10 milligrams of a placebo. So those were your two treatments. You either got Lipitor or you got a placebo. Part E, the response variable, that's what you're measuring. The response variable is the occurrence of any major cardiovascular event. And it says, is it qualitative or quantitative? So this one's pretty general. Was there a cardiovascular event or not? That would be more of a yes or no question. So that would be a qualitative. We're measuring if they had the event or not. There's no numerical measurement going on here. So hopefully that helps you just kind of break down a situation. You'll be doing that same thing on your test, given a situation, and breaking down the different aspects of the experiment. All right. So I just wanted to briefly go over the last page on your handout is page 10. This will not specifically be on your exam. I just want to go over kind of the steps of designing an experiment. And this is just for your information to kind of tie everything together that we've talked about in this chapter. So this is again on page 10 of your handout. So the first thing you do in an experiment is identify the problem or the claim, and we discussed that on Monday. You determine the response variable, and you determine the population to be studied. What am I trying to measure, and who am I measuring, or what am I measuring? And then you determine the factors. What are the effects of the response variable? What can be involved in trying to measure that response variable? What can be controlled? What can be varied? What are some things that we maybe cannot control for? So you really think about what aspects of this experiment are we measuring? What affects what we're measuring? What can we control? What can't we control? And what are we going to vary? That usually takes a lot of time. Then you decide on your sample. You decide on a specific size based on money, based on time, based on resources. There is a specific way to calculate an appropriate sample size, and we'll discuss that more in Chapter 8 and Chapter 9, more about how to get an appropriate sample size. So it's kind of the before. You get your problem, determine what you're measuring, your different factors, and decide on your sample size. And then you decide on different levels for each factors or different amounts. Are they going to have a placebo? Are you going to have the control of no medicine or fake medicine or original medicine, whatever it is you're trying to test? How much of each? Are you going to vary it or keep it constant? Lots of different things to think about. And then you look into actually running the experiment, the fun part. You always need randomization to reduce bias, replication so that your results are more reliable. You want to do as many runs of it as you can afford, so lots of replication, and control as much as you can to make it a well-designed experiment. And then you collect and process your data. And then finally, you have your conclusions. You answer the question. You've tested your claim, and you can answer your questions now. And this is where inferential statistics comes in. That's more Chapter 8, 9, and 10 for us. And you can now make generalizations about the population based on your sample. So again, that's just kind of the full circle, running a full experiment and using the statistics to help analyze your results. All right, so I know a lot of you are interested in how the test is going to be. You do not need a Scantron, you just need your brain and the formula chart, which I will provide you, and a pencil, not a pen. It's mostly multiple choice for this exam. A lot of things are being categorized. Is it this? Is it that? What type of sampling is it? So it's mostly multiple choice for this exam. There is one open sampling question where you'll have to take a sample using the random digit table, which we practiced today. There is open-ended questions at the end regarding experimental design, just like the example we went through. You read the scenario and identify the elements of the experiment. I think it's fairly straightforward. You really just need to be able to have different scenarios and different examples and categorize them appropriately and identify what they are. And that's kind of the structure of this exam. There's 18 questions with a total of 25 parts. This open-ended question has a lot of parts. So it's a grand total of 25 questions. They're 4 points each to make up your exam. If you have any other questions, please email me or come by.